All right, so we have reached our fifth method of solving quadratics. Method 1 was solving by graphing. Method 2 was solving by factoring. Method 3, solving by square roots. Method 4, solving by completing the square. And now finally, method 5, solving using the quadratic formula. Okay, now you probably at least vaguely remember the quadratic formula from having done this before. There it is right there. Okay, but the first thing that we're going to do is you may have noticed when we were completing the square that there were sort of familiar notes that sort of felt like the quadratic formula in there. Okay, so we are going to take a look at that. We're going to show you where this quadratic formula came from. Okay, back when we were when you watch those videos about the imaginary numbers, they talked about how you can use like a particular method to always solve quadratic equations called the quadratic formula. So basically, how this thing came about was somebody took this equation and solved it for x. And when you solve it for x, you get that. Okay, so that is actually what we are going to do right now. We're going to run through a proof of the quadratic formula where we're going to actually transform this. We're going to solve it for x, keeping all the letters instead of numbers. Okay, so it's going to be a little bit weird. Bear with me. This is not something I'm going to ask you to reiterate. So, like, I'm never going to put on a test like question number 5, transform the standard form into the quadratic formula. But it's just something that's kind of cool. And this is sort of a taste of what, sort of real mathematics is like. This is what, like, professional mathematicians, they mess around with stuff like this. Okay, so let's go into this. So the first thing we're going to do is we need to get this so that it's just x squared, right? So step 1 that I'm going to do is I'm going to take this and I'm going to divide everything by a, right, to get it to be just an x squared. So then I've got x squared plus, that's just going to be b over a, x, and then plus c over a equals 0. Okay, great. Now I'm going to move this guy to the other side because we always get rid of our c term. So I'm going to have x squared plus b over ax. And then I'm going to leave that little gap. And when I subtract that from both sides, it'll be negative c over a, right? Okay, so now what am I adding to both sides? Well, I'm taking half of this thing and I'm squaring it. That's what we're adding to both sides, right? So I'm taking half of b over a. So half of b over a, that's going to be b over a, but half of that, so b over 2a, and then squaring that. Okay, so what is that going to work out to? If I simplify that, well, that's going to work out to, the top would be b squared, and on the bottom, 2a squared will be 4a squared, right? So that's what I'm going to actually add to both sides. It's just the simplified form. Okay, so that's what that is. All right, so we're adding that to both sides. Okay, so what is that going to give me here? So I've got this stuff over here, okay? And then these things over here, these are like terms that I can combine together, right? Well, they're not like terms yet, but they're both just fractions. So I want to combine those guys together, all right? So I'm going to do a little bit of scratch work off to the side, so kind of up to the top here, okay? And I'm actually going to turn this around because that's kind of our end goal, right? You can sort of see notes of this showing up, right? So I'm going to turn this around and I'm going to combine b squared over 4a squared and then that minus c over a. So I just put it backwards. All right, so to get common denominators, this guy I'm going to have to multiply top and bottom by 4a, right? So I'll multiply top and bottom on this guy by 4a to get my common denominators. So then I'm going to have b squared and then minus, this is going to be 4a times c, so 4ac, if you will. And my common denominator will be 4a squared. Okay, so that's what I'm going to get when I combine those two together. Okay, so that's how I'm going to write this. So I'm going to write this as x squared plus b over ax plus this b squared over 4a squared that we just added. And then we combined that into b squared minus 4ac over 4a squared. Excellent. All right, we're getting there. Now I'm going to come up here because I ran out of room. Okay, so now, right, we're going to take what we have on the left side and we want to factor this, right? So remember what our trick was, is that you take half of this middle term and that's what goes in your parentheses, right? So half of b over a is b over 2a. So this is x plus b over 2a squared, and it equals this b squared minus 4ac over 4a squared. All right, we're getting there. So now we're going to square root both sides, right? So I'm going to square root both sides of this. So the left side, I'm going to be left with x plus b over 2a. And on this side, I'm going to end up with positive or negative. Okay, and I'm going to kind of do this both top and bottom square rooting, right? If I square root the top, I'm going to end up with b squared minus 4ac. I can't really simplify that at all. It's kind of complicated. But on the bottom, the square root of 4a squared is 2a, right? Square root of 4 is 2. Square root of a squared is a. Okay, we're getting there. Hopefully this is feeling familiar. Okay, and now I got to bring this guy over to the other side to get my like term, or to get my x by itself, right? And they've got common denominators. So when I subtract this from both sides, it's going to end up being a negative b, so it'll be a minus b. But I'm going to kind of tuck it in front. So I'm putting the minus b over 2a first. So the minus b over 2a, but this guy's also over 2a. So I can make it into one giant fraction. And that right there is your quadratic formula. Okay, so that is where this came from. So it's just taking your standard form equation and completing the square on it. And then the answer that you get is the quadratic formula. This is why the quadratic formula always works. It's really just completing the square in disguise. Okay, so the nice benefit of the quadratic formula is that it's just you pop numbers in and you follow a fairly simple process. Like you don't really have to remember steps with a quadratic formula. You just have to remember the order of operations, and it'll always get you to your answer. The kind of annoying thing about it is that a lot of times, a lot of those steps are really unnecessary. So like if it's something that's really easy to solve by factoring, you're better off solving by factoring than the quadratic formula because the factoring will be faster, but quadratic formula will always work. Okay, and it's also like it'll get you your imaginary numbers, it'll get you your complex numbers, it'll get you your rational and irrational numbers. So it is helpful. Okay, all right, so 2 examples. Let's do the quadratic formula. So first thing you got to do is figure out what a, b, and c are. So a is always in front of your x squared term. In this case, it's a 1. B is in front of your x term, and c is negative 10. Make sure you watch out if you're missing a term that you're careful about which one's which, because it's not always that a is the first one and b is the second one. Okay, if we didn't have this minus 6x here, then we just would have 0 as a b term. Okay, so watch out for that. Okay, and then we just plug and chug is the expression. So opposite of b is negative 6, so that's going to be positive 6, plus or minus big square root of b squared, so negative 6 squared, minus 4 times a times c, all over 2 times a. All right, and then when I simplify this, I'm going to do 3 things all at the same time. So step 1, square this. Step 2, multiply that. Step 3, multiply that. Okay, so that's going to be 6 plus or minus the square root of 36. Be careful of your signs here. Negative 4 times 1 times negative 10 is positive 40 over 2. Can add those together, so that's going to be 76 over 2. All right, and then if you can simplify the square root of 76, then you definitely need to do that. Okay, this is an example of a problem where I'm looking at that and I'm thinking, I don't know what goes into 76. What's a perfect square that goes into 76? So this is where I would use the birthday cake method, because I can clearly see that 2 goes into that, and it goes in there, 38 times? And then I can see that 2 goes into that, and that goes in there 19 times, and then, 19's prime, right? So there's my simplified radical. It's 2 root 19. I probably wouldn't have come up with that on my own just looking at 76. Okay, so that's why it's kind of handy to have this square root method, the birthday cake method, if you will, kind of in your back pocket again, just as a useful little tool. Okay, so we ended up there. Okay, and then the last thing that I can do here is I can simplify this. So anytime you have a common factor, it has to be a common factor of all 3 terms. So 1, 2, 3 terms. Okay, and be careful if a number's inside of a square root and a number's outside of a square root, that's not a common factor. But this guy, I've got a common factor between the 6, the 2, and the 2. So I can divide all of that by 2. And that's going to leave me with 3 plus or minus the square root of 19 over 1. But we don't need the over 1. And those are your 2 solutions. All right, this guy over here, okay, the first thing I need to do is just reorder this, get it into the right order of things. So I'm going to put everything on the left side. So it'll be 2x squared minus 3x minus 5 equals 0. So opposite of b, plus or minus big square root, b squared minus 4 times a times c, all divided by 2a. Cool. All right, so those 3 things all at the same time. Negative 3 squared is 9. Negative 4 times 2 times negative 5. Well, that's positive 20 times 2, so that's positive 40, right, over 4. So that's 3 plus or minus the square root of 49 over 4. Square root of 49, that's just 7. So 3 plus or minus 7. And then from there, you're going to have to get 2 separate answers. So 3 plus 7 would be 10. Right? And 10 over 4 simplifies to 5 over 2. So that's 1. And then 3 minus 7 would be negative 4. And negative 4 divided by 4 is negative 1. So 2 different answers. One of them I got by doing 3 plus 7. The other one I got from doing 3 minus 7. All right, and then the last 2 down here. Okay, so sometimes when you're doing the quadratic formula, if you can make your life easier, do, because sometimes the numbers in here can get pretty big. So if you can either multiply or divide to give yourself better numbers, by all means do so. Okay, so like this guy right here, the first step that I'm going to take here is I'm noticing that these are all divisible by 3. So I'm going to go ahead and divide the entire equation by 3 and make this just 1x squared, right, minus 2x plus 8 equals 0. Okay, and what that's going to do for you is it's going to make your simplifying process easier. Okay, so it'll make the parts where you're going back here, you have to simplify your square root and then cancel out common factors. It'll make that part easier for you. Okay, so from here, I would use a is 1, b is negative 2, and c is 8. I'm not going to actually solve this problem because from here it's the same as these 2. Okay, so I don't think that we necessarily need to go through every single step on that. Okay, but I do want to look at this guy here. So this guy's got some fractions in it. All right, so having fractions in it is also kind of a pain in the butt. So what I would do with this guy is I would get rid of that fraction. So just like when we were solving those equations in chapter 1 with the fractions in them, the first thing that I'm going to do is multiply the whole thing by 3. So giant distributive property. 3 times 1/3 is just going to be 1x squared plus 9x minus 60 equals 0. And then I'll use that for my a, b, and c, and I'm not going to have to deal with any fractions. Okay, so make your life a little bit easier. Always try to remember to check for that first. Like you could do the quadratic formula from the equation that we started with, and you would get the right answer. It would be fine. But it'll be faster and easier to use these second equations than the first equations. Okay, so just as kind of a life pro advice tip for you.